I think that was over 2 minutes. So let's open it up to questions. See if there's any questions from students first. And again, yeah, very hard to find a student here right now. Oh, it's a killer, yeah. They all hibernate. Well, they're not hibernating. Okay, let's open it up to the general audience then.
Sure.
Is this on? Gary, I'd like to take a shot at the first question. You're obviously aware of the fact that New York presently has a moratorium on high-volume hydrofracking.
Yes.
There are a lot of people, both in this region and across the country, who would call for a complete moratorium across the United States on high-volume hydrofracking. And one of the problems with that, of course, is it can occur just like it did in New York on almost a political whim. What do you think would be the impacts on price and supply if, for instance, just the state of Pennsylvania were to institute a moratorium on hydrofracking for 1, 2, 3 years?
Right. It's an impact because of the reserve replacement factor. And what I'm saying is comparing our usage of 23 TCF a year to a viable alternative for supply, which is the Marcellus, let's say, and brought forth by hydrofracking, the process, making that efficient. It'll affect price going forward just due to that supply-demand balance, which is sensitive to 1 to 3%, right? You get it out of balance by 1 to 3%, you get major, major shifts in price.
Thank you, Gary, for your presentation. Well done, very informative. You brought to light the importance of the pipelines. That's a very important part of this. Now, the harvesting of the natural gas coming from Pennsylvania, I take it now, is that just being stored right now, or is that actually being used? Are they waiting for the pipelines to come in place?
Yeah. This is the injection season, so a lot of natural gas is going into the ground today. It starts in April, goes through October. It's the traditional injection season. So the gas that's being produced isn't being shut in, it's flowing. So most of the natural gas is flowing to storages this time of year when it's warm. That's the summer use. And this winter, it'll be flowing gas direct to market.
Great. And one other question, National Fuel will seem to play an important part in this, already has, even with the Pennsylvania field. They seem to be a pretty big player in this, are they?
In the Northeast, yes. And as a system, I mean, there's larger pipeline systems. Location-wise, they're on top of most of the Marcellus. I think they own 800,000 acres of production acres in Pennsylvania also.
Thank you.
Hi, I'd like to talk about the slide that you had where you showed how we'll have a net excess of gas in the region 10 years from now. What are your thoughts on what ultimate uses of gas we could find for that in the region?
Right.
I'll give you an example. 2 weeks ago in the National Review, Dow announced that they're going to put one of their first chemical plants back on shore in 20 years. Do you think that the big producers are going to be willing to play ball and write longer-term, more stable supply contracts for that sort of activity to begin?
Yes. First part of your question was involved the increased production and where should it go? Primarily power generation. And I made the statement, 2/3 of our installed capacity to burn gas is unused. The biggest bang for the buck is displacing inefficient coal units. And when I mean inefficient, to produce a megawatt in inefficient units is greater than 10,000 BTUs. So there's a heat rate. Natural gas cogeneration is an 8,800 heat rate, 8,800 units to produce a megawatt. There's coal units that are as high as 15,000. So if you took those off the board, that would soak up most of the excess natural gas that could occur if production continues. And the stability I mentioned in price is the fact that Shell and Chevron and other large firms are coming in and investing over time in the resource. and that'll bring stability to price and supply.
So do you think there'd be any gas left for downstream industrial type projects?
For sure, yeah, and feedstock use of natural gas. Natural gas is the key driver to fertilizer prices, so it has a lot to do with our agriculture also. Fertilizer plants key off of natural gas as a feedstock. So it has a lot to do with our agriculture in the U.S.
One of the earlier speakers was talking about distribution plans prior to the development of high-volume hydrofracking, and the fact that increasing demand around the United States was happening at the same time as there was decreasing supply of gas prior to the development of high-volume hydrofracking. And the earlier speaker said as a result of that, the industry was looking at putting offshore terminals for bringing in LNG,
Right.
compressed liquid natural gas, on ships in order to meet the supply. And the speaker said that that's no longer part of the picture. So I guess I'm wondering what you think is the future for shipping LNG on ships, you know, either in the U.S. or around the world. And the second question, or if you want to take that, and then maybe I could
it's
follow up.
1.5% of our supply in the U.S. right now, LNG. And the problem with it as a supply source, the unreliability is price swings. If Japan needs that resource or Europe, the ship turns and goes there because the price is higher. LNG, Cove Point, there's other large new developments. We have overbuilt our LNG capacity versus our use of it today. And when natural gas was at $12 in 2008, LNG was viable. So at $4 levels, I'm not so sure. And as we increase domestic production, LNG, which is from North Africa, Liberia, South America, Venezuela, will be unnecessary. We'll become a net exporter.
Okay. The other question is, if we have increasing demand, not just in the U.S., but worldwide, especially in the Northern Hemisphere nations, what's the likelihood that there might be some kind of a worldwide pipeline network developed, you know, like utilizing the Bering Strait to even link North American and Eurasian networks?
Possible, very expensive. And you know, the Russian, Siberia is the biggest deposits in the world. So, but linking all that is engineering nightmare. I mean, it's a long way to bring natural gas. And the efficiency is less because of the system loss between points. And there's a line loss factor on any pipeline due to compression. Gas isn't lost, it's compression to move it, primarily using natural gas compressors. So the efficiency of that is not good compared to taking it from 50 miles away, right? But possible. And the worldwide pipeline system, unlikely in the next 50 years.
Gary, I actually got a question too. Builds off of your question here. Are you saying that if we do start, you know, if the local production does go up, that's actually going to be a goad to industries in this, or to industry to move into this area? You know, people that manufacture things. Or anything?
Unlikely. Taxes would overtake that. I think that. I think that no, having it other than power generation cited here, that's one possibility. Fertilizer plants are primarily southeast, and actually, yes, they're located in Louisiana and Texas, where most of the production is. Possible here, I guess. I didn't think of that, but the heavy users and the feedstock users, fertilizer industry, agriculture. As far as, you know, greenhouses use a lot of natural gas, and you see that in Ontario. But the viability and feedstock use of natural gas would increase as the price drops. Go ahead.
Yeah, just wondering, if the U.S. dollar starts to become stronger, and it forces down the price of commodities. Do you foresee consolidation between explorer-producer firms to have economies of scale? And then the second part will be, as the explorer-producers firms start to write down depletion of their properties, do you think the next step will be vertical integration between upstream and downstream firms? And then the follow-up will be, what do you think the price of natural gas would have to be to have national arbitrage opportunities nationwide?
Right. Well, your first part of the question was the consolidation. That's happening now. I mentioned Chevron buying Atlas and then Chief. Shell buying East Resources, Terry Pergola's company. This is happening as we speak, and the need to, the growth needs of the big companies and this play becoming more economic are the drivers. You asked about the change in dollar values. It does affect Canadian natural gas movement to the US. But as a commodity, because of the relatively inexpensive price of natural gas, there's more action in the commodity market there. The natural gas contract, for the first time, traded more than 1 million contracts yesterday, right? That's a 16% change from last year. And that's attributed to the increased physical market that's out there, the new production that's hitting the market. And the fact that as a commodity versus oil, versus metals, versus agriculture, it's relatively low priced. So clearing prices with Marcellus are estimated $2 to $4. There's companies that can make money at $2, right? So if you're selling, if the market price in the US is 4 to 5, they're going to be able to produce this product, and make money.
I'd like to thank you for presenting a factual and yet neutral presentation. Most of them have been slanted. But I got very curious when you mentioned the Rockies. Is it vertical drilling in the Rockies?
Both. And, but most of those discoveries were vertical. And then, the shale out there is different variety, if you will. But it's primarily vertical drilling and horizontal.
How do they protect the water if it's in the Rockies?
The same casings that we saw are used, and the technology exists to protect groundwater and groundwater sources. And they're going deep. Keep in mind, they're going 7,000 to 9,000 feet vertically, and the groundwater is at 1,000. So the casings and the extra protection go a few hundred feet past the groundwater in examples I've seen. Last week detailed, if you were here, an actual well and what they did to protect groundwater contamination by fracking fluids. The removal of water is another thing. But about a third, like I said, gets removed in those high water use wells, and a lot of it stays underground.
You talked about expanding out pipeline as we further develop in the area. What kind of effect does that have on, not effect, but how does the process work with actually creating that pipeline as far as land ownership? Do you approach landowners about use into their land, and how is that orchestrated? Is it set out like a plan?
Yep. Existing rights-of-ways are used generally, but for a new pipeline, if you're a utility, and utilities get the legal rights of eminent domain, they can acquire your rights-of-way. Otherwise, if it's a gathering system, those rights-of-ways are bought, as would a natural gas lease or any right-of-way across your property. So the landowner rights are preserved, and your choice and your economic benefit if you choose to have a right-of-way across your property. Utilities and federally regulated pipelines have eminent domain. So, but the improvements we saw are primarily on existing rights-of-way.
Gary, very good talk tonight. I may have missed this, but do you consider the automobile to be a market?
Sure, yeah, and part of my career at National Fuel, we promoted NGV vehicles. And the issue, so has Boone Pickens. Now, that was his way of promoting end use for natural gas. However, what it doesn't exist is the infrastructure. Even a simple example, our New York Thruway system, there isn't a single natural gas filling station. So what has to be invested is and transportation use works. Locally, we've converted NFTA buses, police vehicles, school buses, passenger cars. The ranges are less, probably 100 miles on a tank. So refueling stations have to be available, and that's the issue. But as a vehicle fuel, it works. The torque is the same, and it's fairly efficient. It compares well to gasoline prices. It's about 60% of the gasoline price.
Would that be Americans doing all this infrastructure work to?
Oh, sure. I mean, it's, we need, the ones that existed locally are gone. We had 4 local refueling stations, and then the momentum died. The utilities are primarily promoting it, and without subsidy, it wouldn't have worked before. There is a difference in fuel costs now, and it favors natural gas. You actually would spend about 60% less, or 60% of your total transportation fuel costs on regular unleaded.
I got another question, Gary, actually. You talked a lot about reversing the flow on some of the pipelines and everything, and then the costs for doing that in a number of cases were between $500 million and $1 billion, something like that. Is that actually going into changing where the direction the stuff is distributed, or is that actually, do you have to change the main pipelines, or can you just use those over again?
Yep, pipeline remains the same, and they add compression to force the natural gas north. So, same pipeline, 24-inch coated steel in a lot of cases to move a lot of volume, and then what was an import point becomes an export point from the U.S. into Canada. And this is something that we wouldn't imagine 5 years ago. We were more and more dependent on that supply, and for price, for availability. And this is prior to the discoveries and the economics of the Marcellus production.
Gary, I have another question for you. Gary? Gary?
Yes,
Sure.
yes.
Try again.
Yeah.
Question on pipeline efficiencies. 2 engineering professors at Cornell recently published a study that compares natural gas to coal as a greenhouse gas emitter and concludes essentially that natural gas may actually be worse than coal. A large part of their study suggests that that's because of what they refer to as line loss, about 7 to 8% line loss. I heard you use the expression line loss a number of times in your talk. Where is this gas going? I mean,
Yes.
how is it being lost from a pipeline?
Right.
I don't quite understand.
A transmission system at 1,200 pounds requires a lot of horsepower of compression to move the volume, and that's fueled by natural gas. So the natural gas pipeline itself will operate facilities that push natural gas through the systems driven by engines fueled by natural gas. An important statistic, coal to natural gas, that I mentioned before, 92% of the fuel that comes out of the well is delivered to the end use in natural gas example. With coal, the equivalent amount of BTUs brought from the ground, just 32% would reach its desired outcome of power, right, after it's converted and burned. So the efficiency difference in fuels is giant. However, the coal is less expensive at this point if you look at it on a million BTU input basis. So the installed capacity of natural gas that I keep mentioning is unused, continues to be unused, because we rely primarily on the least cost fuel, which is coal.
Question over here.
First of all, very well done. I enjoyed the presentation. I have a question on what is IOGA and other groups like IOGA doing to lobby Albany to lift the moratorium here in New York and promote and take advantage of this unique economic opportunity that we have in the region? And what is the general industry consensus on a timeline to get this done?
Well, independent oil and gas in New York are producers, pipeline types, I'm a member. It's promoting local gas. And the latest mission is to see if we can do directional drilling in New York, hydrofracture. There's a large DEC-sponsored SGIS, that's the Environmental Impact Study, that will set the standards for this for the next 30 years. That's being worked on. It's tougher regulation than we see in Pennsylvania, which has prolific production. So possibly within the next 2 years, if we work this through and this outcome of the SGIS comes, that we have safe drilling in New York, away from watersheds, and in areas that we can monitor groundwater and well water. And last week's presentation convinced me that it can be done safely. So that's the momentum. New York State will have a good source of revenue and tax revenue should we develop the resource.
Your discussion about the gas reversing direction going up to Canada and so on, were you projecting that New York State would produce as much gas as Pennsylvania?
Unlikely. The counties southeast of us towards Binghamton, Tioga, Chemung County, the southern tier of New York, between Binghamton and Olean are probably the sweet spot for Marcellus in New York. It exists, southeast of us in shallower formation. Probably not be the producer that Pennsylvania is. Most of that fairway that I showed is Williamsport, those areas in Pennsylvania, and they're far ahead of us. A lot of established wells.
Is the Solarium coal in the pipe dream?
No, and I'll mention this, underneath this Marcellus is the Utica Shale, even deeper, and supposedly a bigger resource for the future. So it's just technology to get to it, and the drilling technique that's being developed to get that deep and move it out. Again, protecting the groundwater is the priority. Or excuse me, the well water is a priority.
Hey Gary, I'd like to follow up on Mike's question. I think I read the same article that he did from a Cornell professor that said there's a 7 to 8% line loss, and I think the implication there was that it's being released to the atmosphere and it's a greenhouse gas.
Yeah.
If I'm understanding you correctly, that's not the case, and it's actually used as fuel and not released into the atmosphere.
Yeah, every system has a loss unaccounted for, so if I had bought 100 decatherms of gas at Leidy and moved it to National Fuel Citygate, 2% volume is gone. And it's not physically gone, it was used to push the product forward. And in storage systems also, there's a base gas. So if I'm storing, I have 60 BCF stored, I have left 60 BCF in the ground, and that's just so I can force the rest out to market. So there's base gas in storages, there's system loss in pipelines, and that's a symptom of the industry. Most people don't realize that electric power has 9% resistance loss. So you'll pay for 100 units and receive 91 at your end use. So it's even more losses, and it's resistance and equipment, as it flows across the wire.
You had mentioned the flow on the pipes is going to be reversed out from the Marcellus region, and that you said there would be additional pipes, I think, that would be needed. Why isn't the existing system adequate? What creates the need for the new pipelines?
Yeah. Volume from these areas, the gathering. So this was no end use, no end use in those areas. However, tremendous production. And so the takeaway lines, just by scope of engineering needs, under high pressure, size lines adequate to move that much natural gas away. And again, primarily using existing rights-of-way. And then when not, you build new lines and you get rights-of-way. And these are, if they're private lines, they're dealt with between landowners and the owner of the system. So I would say that In the US, there'll be quite a few new lines necessary, mostly gathering systems, bringing it to existing transmission lines who can increase their throughput just with compression. Others? Yeah.
Do you have any insight as to the plans for the Finger Lakes, whether they're... Do you have any insight as to drilling plans in the Finger Lakes?
Yes. You know, those on all federal lands and in general, there's not, I think those are barred, right? There was the Finger Lakes National Forest example. It's not going to be drilled on. So there's certain areas that will not see drilling ever. Our National Forest has active drilling programs. Allegheny has active drilling programs. Yes, sir.
Yeah, I was kind of thinking that you were also going to talk about well completion tonight. I was thinking you were going to talk about well completion tonight, and I don't know whether you're knowledgeable in that area or not, but if you are, you know, the guy last week talked about the drilling and fracking, right? And kind of ended at the point where the well had been fracked and it was ready to go into production. So if you're knowledgeable about that and can talk about that, would you talk about what happens once the frack trucks leave and you know, how the gas coming up, I assume it's pretty wet maybe with water,
yeah,
or other sorts of stuff, how that's pulled out, purified, or whatever, you know, the process is, the engineering process, and then eventually injected into these collection lines that, you know, you've talked about a little bit ago.
Gathering lines, yeah.
Yeah, gathering lines.
So completion of the well, there's that flare-off that I showed a spectacular picture of. Most of them don't look like that. And then after that process, before the tie-in, the natural gas from the well could be higher BTUs than a pipeline would accept, moisture content. All these are standards that are met. So dehydration occurs if there's moisture. And then odorization, which is percaptan, is added to give that classic natural gas smell because it's odorless as it comes out of the ground. And then there's certain standards, sulfur content, pipeline standards are enforced such that as it comes out of the gathering systems and heads to a transmission line, there's natural gas stripping that occurs, so the liquids are taken away. Ethane, butane, isobutane is taken away, and the natural gas then, BTU content, stays within a certain range. And what's interesting is the natural gas system locally is getting hotter because of the additional natural gas and higher BTUs per cubic foot. However, there's standards for the pipelines, and pipeline natural gas is 1,030 BTUs a cubic foot. We've seen that local gas that we're using increase in BTU content. And the interesting thing is, if it increased to a certain level, you could adjust your fuel-air ratio and take advantage of that. But it's a subtle change. Gas out of Canada is generally less than 1,000 BTUs a cubic foot. And that's just the difference in movement and BTU content as it comes east. So to answer your question further, the well completion side, there's pipeline quality standards, there's dehydration, chemical content of the gas, et cetera, all within standard. And then when it hits the system, that's when I get involved. We take it away from the meter as proven flows that meet all pipeline standards. So there's no liability for the shipper as well as the end user because it all goes back to the pipeline and maintaining standards of quality that are uniform.
The speaker next week will talk more about that completion issue. Yeah. No, that's okay. That's great. Yeah.
Any other questions at all?
I got
some
one
good
more,
ones.
Gary.
Yeah.
You talked about stuff I don't know anything about, so it's great. Now, is there going to be an effect on, if we keep producing more in this area, is there going to be an effect on our home heating bills? I mean a good effect?
Yeah, I'd say stability. Yeah, the prices may rise slightly. We come off 5-year lows, but next winter looks similar to or slightly higher than this year, which we had a record low last year, a record the last 7-8 years.
Right,
record.
just that price graph.
Yeah, we had less than $4 market price natural gas, and I mentioned $9 3 years ago. So stability in price is the key, and not so volatile, and a lot of it. So a positive effect long term.
Okay, thank you.
I'll throw a question at you. Haven't you seen a decrease in your gas bill?
I don't know, it always looks the same.
It does? Okay. No, you really should have over the last few years, especially this last year.
Yeah, no, I remember last year did look better, but yeah, this year, that was about unusual. It wasn't that unusual.
Right. Okay, and maybe, Gary, if I can just take a minute to answer this gentleman's question.
That's
I think I can just help you a little on it.
Yeah.
When every well that's drilled, these Marcellus wells, at the individual pad, the gas that comes out is under quite high pressure, several thousand pounds pressure, and the fluids are removed right at the wellhead. There's devices called separators where the gas slows down, the water falls out of it that's in there, either frac fluid or production fluids, and that's separated. Then the dry gas goes down the pipeline, and it's generally market quality, other than maybe some residual moisture. It's the right BTU, it's about 1,000 BTU. And any water that comes out gets knocked out at that wellhead and gets collected into tanks and then hauled to different disposal facilities. But it's all treated right at the wellhead.
Awesome.
Thanks, Larry.
Oh, okay.
So different topic. So when you and when other experts look at let's say the gas capacity, the proven reserves and the possible reserves of gas on the North American continent, U.S. and Canada, Alaska, right? I think, I don't know, you didn't mention really Mexico, so it sounds like there's really not much gas comes from Mexico.
Correct, yeah. Mm-hmm.
In oil drilling, there's been the idea of peak oil, right? And I assume that the same idea operates in gas also. That there's the idea of peak gas. There's not an unlimited supply of gas or oil, in the sense of infinite, truly infinite. So I'm curious, how do people think about that question with respect to gas? Mm-hmm. North American gas, not gas coming in, and LNG coming in from overseas.
Yeah. Well, just with the Marcellus and with reserves as they exist, there's a 100-year supply. So an adequate supply for, 2 generations, as well as, discoveries like Utica and other ways to more economically get at the reserves we have. So that's the change. And I think that we have a domestic resource, when it's well done, that will make us totally independent from oil imports. And as we repower the U.S., and as we change our transportation fuels, we're going to rely less and less on imports of oil. That's the goal.
That'd be a good research project for somebody here at UB.
I'd say, yeah.
To study peak gas and get some good fellowship or something, but somebody study that.
Thank you. Do you want to support that?
Geology, yeah.
In the industry, I'm sure be glad to help.
Thank you.
Thank you, Larry. Mm-hmm.
Appreciate it.
Yeah, something to think about.
I'll talk to you later. Any other questions then? Thank you again, Gary.
Hey, you're welcome. Thank you. Thanks very much.